Hello and good day, Algebra. Here we are with a blank piece of paper. It's a blank piece of paper because we are going above and beyond PO50 today, deviating slightly from the binary because I think that you can handle it. There is no doubt in my mind, 100%, yes. You don't interrupt someone in the middle of their monologue. What? You can do this on the backside of 49, the backside of 50. So now we You only get to introduce a lesson once. Thank you for that. Thank you for that. Yeah. I am 100% certain that 100% of you, as we're going through the trinomials in 49 and 50, when you see something such as this, x squared plus 10x plus 21 equals 0, in PO49 and PO50, we learn how to factor these, right? You got your two binomials for what times what equals this. But somewhere in the back of your mind, you were thinking to yourself, okay, but what does x equal?
I never thought that.
Oh, you did. It was subconscious, I'm sure, right? But if this equation equals 0, because we made a big deal about having your equation equal 0 before you factored it. Sometimes you had to move a term over so that it did equal 0 so you could factor it. And so now the question becomes, we can factor it, great. But can we solve for x? Can we solve for the variable? Can we find the value or values, hint, hint, for x that make the equation equal 0? Any thoughts?
Well, we probably could, otherwise we wouldn't be doing it.
We probably can, otherwise, yes, you are accurate there. Okay. What do you think we are going to need to do first in order to solve for x here? We can't use opposite operations here because we have two x terms that can't be combined. That's a problem as far as opposite operations is concerned. But I waited until after we finished PO49 and PO50 because our first step is going to be, starts with an F, ends in actoring. Factoring, good job, okay? So go ahead and factor x squared plus 10x plus 21. Keeping in mind, the coefficient x squared is just a 1, so you don't have to do that 7-step process that we talked about in PO50, right? It's really just steps 2 and 3. You're looking for two numbers that multiply to equal our constant 21, and those same two numbers add to equal our middle term 10. So go ahead and take a minute to factor this. Answer or question? Save it for now, please. What did you get for your magic numbers? Lucas? 7 and 3. Would it matter if you put 3 and 7? No. It ends up being the same because when we go to write our binomials, we start them the same way. In this case, they both start with an x. And then one of them gets the 7, and one of them gets the 3. Okay? Now, everything that we've done so far has only been on the left side of the equal sign, right? We factored that expression to get x plus 7 times x plus 3. What does x plus 7 times x plus 3 still equal? 0. But in this form, can you give me a value or values for x that will make this equation equal 0? Yeah. Well, if x equals 0, then if we plug in 0 for x here, we get 7. We plug in 0 for x in the second set, we get 3. 7 times 3 is 21. Daniel? -7 and -3. Why, Daniel? So if we plug in -7 in for x here and get -7 plus 7, we get 0. Does it matter that in the second set, when we plug in the 7, because we can't make one x -7, the other x negative 3 in the same equation at the same time. That's not how variables work. But if we plug in negative 7 in for that second x as well, does it matter that we get a negative 4 here? Why not? Yeah. Because 0 times anything, no matter what that second set is going to equal 0. So negative 7 is one of our solutions because negative 7 makes that first set of parentheses equal to 0. And then negative 3, we plug in negative 3 into the second set to get negative 3 plus 3, which equals 0. Does it matter that negative 3 plus 7 is a positive 4? No, because 4 times 0 is going to equal 0. So essentially, once you get this down in a factored form, what we're looking for is what value for x makes our first set of parentheses equal to 0, negative 7. What value for x makes our second set of parentheses equal to 0, negative 3. Who's having like a mind-blown moment here? Just me? Soybe? Thank you for that. Okay. All right. Questions so far?
Nobody raised their hand.
It was kind of a...
Okay, so we've got 1 out of 20
billion.
There are people, my many subs at home are probably...
217.
Yeah, something like that. Okay, now how do we go about checking this? How do we go about checking this? To make sure that we have the correct values here, yeah. Same way you check a value in any other equation, you plug it back in, okay? So you take that negative 7 and make sure when you square negative 7, if you're using a calculator, you put parentheses around it, because what you don't want to happen is for your calculator to put in like that, and this is going to give you a negative 49, because your calculator is only going to square the 7. If x is negative 7, that means we're squaring negative 7, so it needs parentheses around that to get a positive 49, okay? Plus 10 times negative 7 plus 21, so 49 plus negative 70 is a negative 21, plus 21 equals 0. Negative 7 checks out. We then have to check a second time with negative 3, because we can't put negative 7 in for the first x and then negative 3 in for the second x. Like we said earlier, an x can't be different values in the same equation at the same time. So we plug in negative 3 in for x now. Negative 3 squared is positive 9. 9 plus negative 30 is negative 21. Plus 21 equals 0. It checks out. Negative 3 squared is a positive 9. And then 10 times negative 3 is negative 30. So 9 minus 30 is negative 21. And then plus 21 gets us to 0. Yes?
When you factored it to get 7 and 3 and put it in parentheses, is it always just going to be the opposite?
So Brent's noticing here that we have x plus 7, negative 7, x plus 3, negative 3. Yeah, pretty much, right? Because if we're looking to get 0, we want the opposite of positive 7. We want the opposite of a positive 3. Okay? Bridget. So this will be on the test as extra credit. Okay? So if you got to this point here where you factored it, then everything's fine. Okay? You'll get 100% there. But if you go the extra mile and solve for x, there'll be extra credit opportunities there for you. Yes?
Should you just raise both?
Yes, you do need them both. Yep, you do need them both. Okay, let's do another. And I'll let you kind of take this one on more so yourself. Let's go x squared minus 13x plus 40 equals 0. Solve for x in that equation. And your first step here will be to factor. What's that? Okay. To get you started, two numbers that multiplied equal 40. Those same two numbers add to be a negative 13. What are the magic numbers you came up with? Julia? Negative 5 times negative 8, negative 40. Negative 5 plus negative 8, negative 13. So our parentheses, they both start with an x. One gets a negative 5, one gets a negative 8, and that equals 0. That's the factoring piece. You can do that. You're fine for the test. Next step is to solve for the variable. What values for x make this equation true? Gabby? X equals 5 and x equals 8, right? What value for x makes this set of parentheses equal to 0? Positive 5. What value makes this set of parentheses equal to 0? Positive 8. Okay? If you want to check these, plug in 5 for x, and you're plugging 5 in for both x's if you're checking that value. Do you have to check it? You should always be checking your work. 5 squared is 25. 25 minus 65 is negative 40. Negative 40 plus 40 equals 0. It checks out. Okay? How we doing? Decent? Okay? Because next level. What do I press? Why can't, snipping. I don't want to do that. Okay. Next one. Four x squared plus 15x plus 9 equals 0. What's different about this one than the previous two, Lucas? It's got a coefficient x squared, which means we're in PO 50 now, which means you've got to go through that 7-step process to factor it. But again, if you can factor this, then for the test, you're fine. Okay? We're going to be going over that extra step of solving for the variable, which is extra credit opportunities for you. There is no greatest common factor that we can take out of here, so we can skip step 1. We're essentially going straight to steps 2 and 3, which are two numbers that multiply to equal 36, right? When you have that coefficient to x squared, you multiplied a and c together. So 4 times 9 is 36, and those same two numbers add to equal our middle term of 15. When you get the magic numbers, raise your hand. If you'd like to share the magic numbers, you can keep your hand up. Josh? 12 and 3. If you put 3 and 12, does not make a difference. Okay? Now to set this up, really just like the last couple, the other ones both started with an x. In this case, these will each start with a 4x, right? That a term. And because we start them the same, it does not matter which one gets the 12 and which one gets the 3. We make up for that in step 5 when we simplify one or both. And in this case, we can simplify the first one. Divide by 4, divide by 4. And we get x plus 3. And our second set doesn't change. And because we haven't done anything to the right side of the equation yet, this all equals 0. Okay? If you can do that, if you got that far, you factored it, you're good. For extra credit now, what does x equal? Gabby? Negative 3, right? Thankfully, one of these is pretty easy to see. What value for x makes that equal to 0? Negative 3 plus 3 equals 0. But what about that second one? What value for x, when you multiply it by 4 and then add 3, gives you 0? And thankfully, if you can't figure it out mentally, I mean, recognize that what we're doing is we're trying to find what value for x makes 4x plus 3 equals 0. You can set up a two-step equation to solve this, right? We want to know what value for x makes 4x plus 3 equal 0. So we subtract 3 from both sides. We divide both sides by 4. And we get negative 3/4, or 0.75, as a decimal. Negative 0.75, yes. Yes. Okay. Questions on that one? Lucas. Yes, this is the answer I'm looking for on a test. If you provide me with this part here, it's extra credit. Okay?
Are we going to put it that it's extra credit?
I'll remind you, yeah. And yes?
How come with the first one, the x could be different, or it could not be different, but the x could be different?
We had different x values for the first ones also. Like for the very first one, I think we had, what, negative 3 and negative 7?
Yeah.
Different values there. And the last one we had 8 and 5, right? So these are different x's. It's kind of the same. When you go in to check it, you're only going to plug in negative 3 in for the first x, negative 3 in for the second x, check that answer. And then negative 3/4 in for the first x, negative 3/4 in for the second x, check that answer. So you kind of check them separately, but they can be different values. Yes?
On the test, would you want both of the answers?
Yes, both answers are required. Okay? All right, another one. And I'm going to keep this in mind here. We'll come back to it later. Okay? All right. The one I'd like you to do, and see how far you can get on this one yourself. I'd like you to do 20x squared minus 38x minus 4 equals 0. Your first goal should be, can you factor it? If you can factor it, then you've got the objective for PO50. If you can then go the extra mile and solve for x, kudos. But practice factoring first. And my many subs, you can be doing this now too.
What? Oh.
So this one, there is a greatest common factor. So your first step, if you choose to factor, will give x squared minus 19x minus 2. If you didn't factor it out, that's okay. Your numbers are going to be a little bit larger that you are working with here. But now you're looking for two numbers that multiply to equal negative 20, which is the product of A and C, 10 and negative 2. And then those same two numbers add to be our middle term of negative 19. And what magic numbers did you come up with? Lucas? 1 and negative 20. If you put negative 20 in 1, that's okay. Now, to set this up, we've got our GCF out in front. They both get a 10x. One gets a positive 1. The other one gets a negative 20, and that still equals 0. Now we simplify one or both of the parentheses. We can divide this one by 10 and by 10. So that gives us 2 times 10x plus 1. And this one becomes x minus 2. I like that. And our final step, distribute the 2 into our parentheses here, just that first set. And so our final factored form, we have 20x plus 2 and x minus 2. Brent.
For the last one, you had 4x squared plus 15x plus 9, and then you multiplied 9 by 4, and then you had to factor out 36. Was I supposed to do that on this?
Yeah. What you just described is kind of those steps there.
Oh, yeah.
Did you factor out the 2 first?
I did 20 times 4.
Okay.
20 times negative 40.
Okay. So then you got 2 and negative 40?
Yeah.
Yeah. You should still get.
Yeah.
Yeah. So that's fine. Yeah. Factoring out that greatest common factor is optional, but it does make your numbers smaller. And 10 times or 20 times 4 isn't that hard to work with, but if it was something greater than factoring out that GCF is a big help. Okay. So we're here now. And we're looking for what values for x make this equation true. If you got this far, you factored it, everything's good. If you have a slightly different answer than this, that might be okay, right? It kind of depends on whether you put the positive 1 and negative 20, or if you put your negative 20 first and your positive 1 second, then you'll get a slightly different answer. That's okay. What x equals will still be the same thing. Okay? But what values for x did you come up with here? Josh. X equals 1. I think x equals 2. And the other one you got was negative 1/10. Okay. I can see where the 2 comes from here because 2 minus 2 gives us 0. But what about that negative 1/10? How'd you come up with that? Well, because you're right. But how'd you come up with it? Sure. You can set up a two-step equation, 20x plus 2 equals 0. Subtract 2 from both sides. 20x equals negative 2. Divide by 20. And negative 2/20ths simplifies to be negative 1/10. Okay? Guess what, folks? Yes, Erica.
Isn't 2 1/10 like 2 over 20? Yeah.
Well done, Erica. There's another way, rather than setting up this two-step equation. Not that this is a whole lot of work anyway, but we all like that shortcut way, right? Take a look at our last one here, 4x plus 3, and our solution of negative 3 over 4. And take a look at this one here, 20x plus 2, and our solution of negative 2 over 20, which then simplified to be negative 1/10. Does anybody see any sort of connection or relationship here? Elise. Right. When you've got a coefficient in front of x, like we did here with that 20x plus 2 and that 4x plus 3 here, you can set it equal to 0, yes. But the shortcut is to take the opposite of your constant. Positive 3 becomes negative 3 and divide by your coefficient. Positive 2 becomes negative 2 and divide by our coefficient 20, which you would then simplify to be negative 1/10. If we had something like 5x minus 3, the opposite of negative 3 is a positive 3 divided by 5. 3/5 would be your answer for this. Who thinks it got a pretty good handle on it? Who's impressed with how cool algebra can be?
One hand. 3. I mean, it's pretty
3 times as many as last time, so So there you go. Okay. Who's at least happy that this is extra credit on the test? How many hands now, Brent? So there you go. Okay. All right. So there you go. We are in. Okay. So why we factor stuff? Factoring is kind of the grunt work to get to solving. You know when you go to a basketball practice and your coach has to spend like 15 minutes dribbling 2 basketballs with both hands at once? You ever done that before? And you're like, Coach, why am I doing this? This is actually literally illegal in the game. Why am I? It's the grunt work to get better at the skills, the big picture that you will use in the game. We factored, which may not have seemed like it had much of a purpose. We factored so that we can solve for the variables, which might also not seem like much of a purpose. But what's coming, what these values represent, who remembers what type of graph this quadratic equation makes? When we were to graph it on the corner plane, what is it going to look like? Parabola. Parabola is like a big old smiley face or a big old frowny face, right? What we're finding here, the solutions for x in this parabolic equation are where this parabola is going to cross the x-axis.
What about the y-axis?
Well, there's a different thing for that. We'll cover that later on. But why do we care about where this crosses the x-axis? I saw a number of you yesterday, more so in ATC actually, or in geometry, on your phones watching the twins play during class yesterday, right? Okay. When Nelson Cruz pops a home run and it immediately tells you how far the ball went, do you see someone running along with a tape measure doing that? No. What they do is they take the path of the ball. Here's home plate here. The ball's hit. It flies out of the park. It lands here. What they found are the x-intercepts of that parabola. Where did it leave? Where did it land? How far was that distance? And again, no, they don't have someone actually measuring that, but what they do is they take the entire ballpark, they computerize it, and so basically they've programmed the computer to say, the ball lands here, how far is that? But it all goes back to parabolas and the stuff that we're doing right now. It has a purpose. We just got to get through some of that prep work first.
I would have learned.
You would have gotten the tape measure, you'd have volunteered. Well, that's what they had to do in the olden days, before they had computers. They had to pause the game for like a half hour to put together a whole bunch of rulers. Took forever. Baseball game took days. Yeah. All right, folks, that's how you math.
Don't forget to like